Okay, in today's lesson we're looking at the rest of the June 2012 paper, the questions that we haven't covered in the previous sessions for revision. Okay, so first of all, question 1. It says the diagram shows 3 angles on a straight line, and we've got to work out what x is and use that to work out the size of the smallest angle. Okay, so we've got 2x plus 3x plus 4x, 2x plus 3x plus 4x, and we know that they've got to add up to 180 because they're on a straight line. So altogether that makes 9x equals 180, so x equals 20. Now the question asks us to work out the size of the smallest angle, which is 2x. So the smallest angle, 2x, equals 40 degrees. And that was question 1. Question 2 was about quadratics. We've already done that in a previous session. Question 3. Here, a base for a shed has a volume of 3.8 cubic meters. 55% of the base is concrete, the rest is steel. A lorry delivers ready mixed concrete in loads of 6 cubic meters. How many of these bases can be built with 5 loads of concrete? So it's just a question of getting your head around all of the information in this. So the question is about how much concrete is delivered, so we need to work out what 55% of 3.8 cubic meters is. So concrete needed 55%, so 55 hundredths of 3.8, so times 3.8, 55 on the top and 100 on the bottom for 55%, and then 3.8 on the top for the 3.8 cubic meters, and that comes to, well, I'll just get my calculator. $2.09. A lorry delivers ready mixed concrete in loads of 6 cubic meters. So it's a question of how many bases can be built with 5 loads of concrete. Okay, so 5 loads of concrete, 5 lots of 6 cubic meters. That's right, concrete available is 5 times 6, which is 30. Let's put some units on this. Cubic meters. So how many bases can you build? Bases. So you've got 30 cubic meters divided by 2.9 that you need for each base. 30 divided by 2.09 is 14.35. Now, you don't want to build 0.35 of a base, so you have to round that down to 14 bases that you can build. Okay, here's the next question. A shape is cut by making an equilateral triangle from a square. So an equilateral triangle, that means all of the sides are equal and all of the angles are equal, and they're 60 degrees because 180 divided by 3 is 60. So that means the bottom of this triangle is 5.2 because it's the bottom of the square, and because it's an equilateral triangle, all of the sides are 5.2 as well. So basically we've got this shape here that's made up of lots of 5.2s because they're all either the side of the square or the side of the triangle, which are all 5.2. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Let me just check I've counted that right. Is it 8 or 9? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So the perimeter, or the distance all the way around, is 8 times 5.2, which is, mental arithmetic, 41.6 centimeters. Okay, next question is question 6, all about bearings. Now, you need to know what a bearing is. A bearing is a clockwise direction from north. So the bearing of B from A is 55 degrees, because if you're at A, then you have to turn 55 degrees clockwise from north to be headed for B. So the question concerns working out the bearing of A from B. So you're at B and you want the bearing of A. So the direction you have to turn clockwise from north to be headed for A. So it's this angle in here. Now, it's given you a formula for it. T equals F plus 180, where F is the bearing of B from A. So in other words, it's telling you that you take the 55 and add 180, and the bearing of A from B is 235 degrees. Now, there's a couple of things you need to know about bearings. First of all, rule for reverse bearings: add or subtract 180 degrees. So, for example, the bearing of B from A was 55. You add 180, you get the bearing of A from B, 235. If you want to go the other way, you take the 235 and minus 180 to get the 55. So if you know the bearing from one place to another, to get the reverse bearing, it's always add or subtract 180 degrees. And that's to do with the fact that the north lines are parallel to each other, and your rules about angles come into play, because if you extend this north line, the 55 here is the same as the angle in here, and then plus you've got an extra 180 in here. But just remember the rule for reverse bearings: add or subtract 180. I don't know if you can hear my son singing in the background. Okay. So use the diagram and the formula to work out the bearing of A from B. Well, we've just done that. So 55 plus 180 equals 235. The other thing you need to know about bearings is that they ought to be expressed in 3 figures. So the bearing of B from A is 055 rather than just 55, and of course the other way around. Well, 235 is 3 figures. The reason for that is, well, this all has its origin in when ships or aeroplanes were instructed to head on a particular direction, and if there was a breakdown in radio communications, you need to know that you've heard all of the figures. So if you just heard 55, it could be 055, or it could be 155 or 255. So for that reason, you always read out 3 figures for a bearing to be sure that you've got them all. Okay, give a reason why the formula can only be used. Just a minute. Hang on, Sammy, I'll be with you in a minute. Sorry about that. The other thing, a bearing has to be between 0. Starts with W, Sammy. W. Okay. And a bearing has to be between 0 and 360 degrees, because a turn from north can be anything between 0 and 360 degrees. Hi, Sammy. Sorry about that. And if you're more than 360 degrees, you're coming back round to the start again. So give a reason why the formula can only be used for between 0 and 180 degrees. Just a minute, Sammy. I'll be with you in a minute. Because outside of this range would give a bearing that is outside the range 000 to 360 would be the answer that would give you the 1 mark. Okay, I better see to my son here. Okay, there's another bit to this bearings question. It says the bearing of C from D is 342. Work out the bearing of D from C. So work out the reverse bearing. And, well, I just told you a rule for it. You have to add or subtract 180. Now, if you add 180, you'll get something that's more than 360. More than 360. So you have to subtract 180. 342 minus 180 is 162. So if the bearing of C from D is 342, the bearing in the other direction of D from C is 162. So just remember that rule for reverse bearings. Add or subtract 180 to get an answer that's in the range from 0 to 360. Okay, question 7 we did. It was all about Pythagoras. And then question 8 is all about angles. Now, there's lots of rules about parallel lines and angles, which you should have learnt in about 5th class, hopefully. Line B and D are parallel lines. That means that this angle and this angle are the same. So W plus 40 equals 72. And from that, of course, we can work out what W is. Just take away 40 from both sides. W equals 32. Okay, so this angle is 72 because it's 32 plus 40. And this angle in here, 2W, so that's 2 times 32, which is 64. 2W equals 64. We work out directly from W. Now, the angle at the top here, when we've got 2 lines that cross over, the angles are equal. So that's 72 as well, because the angle opposite it is also 72. It's odd that they haven't labelled that, so I'll call that E. And then I'll just go up here, and then I'll say that angle AEC equals 72 degrees. Opposite angles are equal. Good to give a reason there. And then we've got to work out T. So we know 2 of the angles in a triangle, so T is just the other one. And here comes my 2-year-old, so I'll just finish this one off and see to him. So T equals 180 minus 72 plus 64. So that's 180 minus 136, which is 44 degrees. So the angle T is 44 degrees. Okay, on to question 10, which is just basically arithmetic. So it's a test of whether you can keep track of all of the information. Not much actual mathematical knowledge in this. A little bit about areas, that's all. So read the information. Hall has length 15 and width 10, 15 by 10. The stage is a semicircle with diameter 6 meters. So in other words, the radius is 3 meters. which we're going to use later. The maximum number of people in the standing area allowed is calculated using a formula. Well, we need to work out the standing area, what the area of that is in meters squared. So it's basically the rectangle, but then you're taking out half of a circle, and that's the area that people are allowed to stand in. So I'm going to write standing area equals rectangle area minus semicircle area. Now the area of the rectangle is just the 15 times 10. The area of a semicircle, well, it's a semicircle, so it's a half times, and then the formula for the area of a circle, pi r squared, where r is the radius. Okay, so the 15 times 10 for the rectangle is 150. That's easy enough. And then a half pi r squared, so 1 on the top, 2 on the bottom, times pi on the top, times, and then we decided the radius was 3 because it was half of 6, so times 3 times 3 for r squared. So the rectangle is 150, and then the area of the semicircle, a half of pi r squared, which I'm just about to work out. So 1 times, I hope I've got a button for pi, times pi times 3 gives me the top, 28.2, and then divide by the bottom, which is 2, divided by 2, 14 well, let's round that to 14. Okay, so the rectangle is 150, the semicircle that is the stage is 14.4 meters squared. So subtract the 2 to get the answer, which is 135.86. And the units aren't there for us, so I'll put them in meters squared. Except I've just realised why the units aren't there, because the question is work out the maximum number of people, so always read the question there. So 135.86 meters squared is the area, and then you've got to take that number and divide it by 0.3 to get the maximum number of people allowed. So 135.86 divided by 0.3, maximum people equals the 135.86 divided by 0.3 equals 452.887, that rounds to. But of course you can't have 0.87 of a person, and you can't have over the maximum. So even though that's nearer to 453, that gets rounded to 452 people as the maximum allowed in the concert. So just about the right amount of work there for 5 marks. Okay, moving on. Question 11. A rectangle has length x and width y. You're given that x over y equals 5 over 2. So x over y equals 5 over 2. The 2 dots in a ratio essentially means divide. So you could write that down and you'd probably get the mark for it, but I like things to be a bit tidier. I don't like fractions. So I'm going to multiply both sides by y to get x equals 5y over 2. And then I'm going to multiply both sides by, let's just go up here. I'm going to multiply both sides by 2 to get rid of the other fraction. So 2x equals 5y. And for an equation to be neat, it ought to be one thing equals another thing. So I'll divide both sides by 5. So it ought to be something like x equals something or y equals something to be nice and neat, is what I'm trying to say. Y equals 2/5 of x. So a neater form of the equation would be y equals 2/5 of x, or if you prefer, 0.4 x. So, you'd probably get the mark for x over y equals 5 over 2 because it is an equation that connects x and y. But writing it in this form, y equals 0.4x, well, A, it's neater, and B, actually it's going to help us with something later on in the question. Write down an expression for the perimeter of the rectangle in terms of x and y. So the perimeter is just the length all of the way around, so it's y plus x plus y plus x, or in other words, 2x plus 2y gets you that 1 mark. Work out an expression for the perimeter in terms of x. So we've just given it an expression for the perimeter, 2x plus 2y, but we want something that's just got x's in it. And this is where we're going to use what I did in part A, because if the perimeter is 2x plus 2y, I know that y is 0.4x, so I can replace the y with 0.4x. Just in terms of x, the perimeter is 2x plus 2 times 0.4x, which is the same as 2x plus 0.8x, or 2.8x. So that's probably that's probably the kind of part of the question that will separate an A grade candidate out from the rest. So it's not something you need to have got 100% right unless you're aiming for a top grade. But there it is. Okay, question 12 we have done already. It was trigonometry. So let's just move on to question 13. Now it looks like it might be about quadratics because it's got some x's that are getting multiplied together to make areas and volumes. But actually it's much simpler than that. So we've got this cuboid box, and it's told us the sides in terms of algebra: x, 5x plus 1, 2x plus 3. But it tells us that the length is 5 centimeters longer than the width. Okay, so the length, 5x plus 1, and the width, 2x plus 3. The length is 7 centimeters longer, so you need to add 7 to the width for those two things to be equal. So 5x plus 1 equals 2x plus 3 plus another 7. And we can just tidy that up and find out what x is. So 5x plus 1 equals 2x plus 3 plus 7 is 10. Well, I don't like x's on both sides, so I'll try and take away as much x as I can from both sides. So if I take away the 2x from here, then I have to take away 2x from the other side, leaving me with only 3x. So 3x plus 1 equals 10. Trying to get the x on its own, so I'll take away the 1. 3x equals 9. Divide by 3, x equals 3. So now we know what x is. We can work out the volume of the cuboid. So the volume is x times 5x plus 1 times 2x plus 3. We know that x is 3. We know that 5x plus 1 must be 16 if x is 3. And then 2x plus 3, 2 times 3 is 6, plus 3 makes 9. So the volume is 3 times 16 times 9. I'll just get the calculator on that. 3 times 16 times 9 that can't be right, can it? Let me just try that again. 3 times, I think my fingers are too fat for this. 3 times, let's clear everything. 432, that is the correct answer, centimetres cubed. Okay, question 14 was circle theorems, we've done that. Question 15, that was quadratics, we've done that. 16 was proportion, we've done that. So we are actually on to question 17, and that is the last one we need to cover, because questions 18 and 19 we have also already done. So let's get to work on this. The diagram shows an arc AB of a circle. So an arc is the curved part of a circle, or a curved section from a circle, I should say. And the center of that circle is O. So what we've got here is like a pizza slice, if you like. And of course it's not drawn accurately, so it doesn't quite look right. This is a bit too curved for this to be the center, but that's done intentionally so that you don't get answers from measuring diagrams. Triangle OAB is equilateral. That means all of the sides are 8 centimeters, not just the one marked. Work out the length of arc AB. Okay. Well, because it's an equilateral triangle, all of the angles are the same and they're all 60 degrees. 180 divided by 3. So that is 60 degrees out of 360. So it's 60 360ths of the circle. Now, if we had the whole circle, then the circumference, my son's just calling me there. Just a minute, Sammy. Just take it downstairs. You have to take it downstairs. Get the battery on it. Okay, turn it off then. Yeah, the whole circumference or perimeter, or in Danish, omkreds of the circle would be 2 pi r. 2 times pi times the radius. But we've only got 60 degrees out of 360, so it's 60 360ths of 2 pi r. Go down and ask more, Sammy. Go down and ask more. Okay, so 60 on the top, 360 on the bottom for 60 360ths, times for of 2 times pi times the radius, which is 8 centimeters, because well, it's on the diagram that the radius of the circle is 8 centimeters. So I'll just make that into a big fraction and find my calculator. I wonder where that went. Okay, here we are. So get everything clear. 60 times 2 times pi times 8 means that the top is 3,000 and something, and divide that by 360. 8.37. So the arc is 8.3, well, that rounds to 8.38 centimeters is already there. So that's the answer we've got. And then finally, just look at the diagram. Is it reasonable in the context of the diagram? And certainly if that's 8 centimeters there, it's perfectly reasonable for that slightly curved bit to be a bit bigger, 8.38. So that's a reasonable answer. Okay, so that's it for the June 2012 paper, and tomorrow we will go through the remaining bits of the November 2012 paper.